Hello guys, I'm Keerthi and I'm an associate data scientist in Red Hat. I'm gonna present on the topic that smarter RAG, smaller builds, so we can optimize for the performance and price. So before we get into it, we all have used RAGs. It has been the most cost efficient rather than other lang chain and other kind of generative AI applications. So here now there have been improvements in MCPs and everything, but still people are building RAG applications in enterprise level and everything. So here I would suggest some on based on my research, I have found some techniques like where we could reduce the costs and we by one method. So there have been many limitations to RAG systems actually. There is data redundancy, like the LLM has to retrieve the same information again and again based on the user request, and slower response times because it is retrieving the data from huge documents and everything. And there is scalability issues because it is handling larger data sets. And also there is rising costs because when we have a larger number of API calls, the costs are also increased. So what is my solution is that RAG caching. I don't know whether many of you have heard, but we can cache our RAG. So we can tackle the inefficiencies of traditional RAG systems, and it optimizes the frequently accessed data, so significantly enhancing the performance. So how it stands out is that there is an efficient data storage in our application. So you whenever there is a repetitive number of requests for one information, it gets stored as cache. So it doesn't have to be retrieved from the document again and again. So it is a much computational process. So it also reduces the latency time and everything. So it increases the speed, and it also reduces the cost actually, and it is dynamic and adaptable. So when we request for new information, the caches also get updated based on the current information. So how does the infrastructure work is that a RAGCache has an RAG controller cache retriever. So the RAG controller actually orchestrates the interactions between the LLM inference engine and the cache retriever and the external database. So when an user inputs a query, it goes to the external data, queries the external database, and the RAG controller will do a method called PGDSF, that is prefix aware dual size frequency replication policy. So, sorry, it's a replacement policy, which ensures that it caches the most critical key value tensors. So whatever query you're doing, the answers will have key values which is stored in the in-memory KV cache, and the cache retriever will get the caches and will be sent to the LLM inference engine and sent to the user as the output. So when there is no output, there is no matches to the key value tensors, it will generate a new token actually. So based on the prefix like of the key value tensor, the matching happens, and so we can control the RAG control orchestrates the RAG pipeline, so it can generate the outputs based on the caches. So it is based, how does it work internally? It is all the documents are stored in a knowledge tree here. So yes is the shared system prompt. So here how it manages is that there is a streamlined process where smart query matching. So it instantly serves the answers from a cache if the match exists, skipping external retrieval. It will not go to the external database. And adaptive cache updates. So it learns usage patterns and updates the cache with high demand knowledge. Like when this knowledge is more needed, it will update the cache and removes the outdated data. So dynamic expiry, it also discards the old information to ensure the cache always is accurate and up-to-date knowledge. And usage insights, it analyzes the query trends. Like if more users are asking the same questions, and it will prioritize caching of frequently accessed information. So fallback to retrieval, it fetches data externally if there is no cached information regarding the query, and it adds it to the cache for future use. So how well does it perform? Actually, this was performed with Mistral 7B and Llama 2 7B. There has been many improvements in the models, and still the RAGCache is performing well in Llama 3 and the further Mistral models actually. So RAGCache reduces the average time to first token by about 1.2 to 4x times and 1.1 to 3.5 times compared to the vLLM. So it is under the same request rate. So this is because that RAGCache utilizes GPU memory and host memory to cache the KV, and it doesn't avoid it avoids frequent recomputation. So due to faster request processing, the RAGCache achieves 1.3 times higher throughput than vLLM. So you can observe from my explanation how is it. It sounds like an FAQ. Like the cache will be similar to an saved as an FAQ, which is very static, but it is totally different. So here you can see that based on the data retrieval, FAQs are very static answers, which is given by the human and to predefined question, which is stored manually. But here it is done automatically by the machine, and it is relevant to the data queries asked by the users. So adaptability, FAQs are adaptable only with human intervention. We have to go and update, but here the RAGs automatically get updated with the newer cache. And the response time is, of course, the RAGCache will give the faster response, and FAQs also has fixed response times. So scalability, this one is highly scalable. For FAQ for larger documents is not at all possible. It is possible, but it requires more manual time and everything. And there is many customization, efficiency, and also the user experience is built, is enhanced, and also we can get dynamically adjust the responses based on the context. So maintaining this RAGCache will be easier than maintaining the FAQs. So the key benefits have been, as I've explained in the previous slide, it is the improved user experience and faster response times, and also it reduces the computational overhead by avoiding the repeated external queries, and also it leads to better interactions, whether it's a chatbot, recommendation engine, or content generator. It gives higher user satisfaction. So I've explored, there is an open source library, GPT Cache. Whenever you guys are building a RAG application, this could be a very useful one. So there are many other applications, like we can use Redis, Memcached and everything. But GPT Cache is an open source library, and there are very less contributors in it. So you could use it, and you can enhance the application. So when you are building any RAG applications, so GPT Cache is a semantic and not exact. So it doesn't look for exact text matches like similarity, keyword similarity. It uses the embeddings to understand the meaning of the query. So it is context based. And the remember and reuse loop, when you send a query, the GPT Cache first checks its database for semantically similar query, whether it has answered before. So it saves money and boosts speed, which gives the much faster response. So the key features, as I've said, the cost and latency reduction, and modular. It is very modular and customizable. So we can easily swap out the components like vector store. Like it is very universal. Like it works with wide range of databases, like include SQLite, PostgreSQL, and vector databases like VV8 and Quadrant. So we can easily swap out other vector databases, and it will not change actually. So the real world application, of course, the RAGs and everything are applicable in most of these domains only. Customer support systems, which allows the virtual assistants to respond faster, and also it will reduce the wait times and give customer satisfaction. And e-commerce platforms, personalization engines. Nowadays, there are e-commerce engines where recommendation systems are built based on the generative AI, and it instantly retrieves user preferences. When user preferences are saved, it can automatically change based on the user interaction actually. And healthcare application, the RAGs have been used, and it will be used for prior diagnosis, and which can enable accurate clinical decisions. And content generation tools, of course, it is used for content generation for many kinds of people, for writers, creators, and finance and banking, yeah, it accelerates the advisory systems by instantly retrieving the market trends and also historical data and client portfolios. So that's it, my talk, and I have explored these kind of cost reduction techniques in my application. I have been successful with larger data sets. So I hope you also found some useful tools to integrate in your RAG applications. Thank you so much. If you guys have any questions, you are free to ask, and we could discuss further in the outside too. Yeah. Yes, sir.
So something I was trying to understand. So a lot of my understanding of RAG is usually it's text-based.
Yes.
That you make a query, you're going to get back documents in text, and you're going to include them in the context, which is in text, and you're going to send that to the LLM. Is the RAGCache somehow returning text? Because I saw on the diagram that it said it was using the GPU memory.
Yes.
And I didn't understand that enough.
Yeah, actually, yep, actually it is stored in the knowledge tree. Here every words of the documents are converted to vector values actually. So it's on mathematical values. So it will be assigning a key value tensor. So everything will have a key based on the prefix value. There is like a much more mathematical computation here, which will be stored in this knowledge tree. So when you have a document, like you have to access 2-3 documents, in this knowledge tree, D1, D2, it will search and go through these documents. And when there is the matched key value tensor, it will retrieve it easily. But instead, when you have to retrieve it from the external document, it has to read multiple lines and get it. So it is much complex than this tree actually. And if we don't find that exact tensor, it will go back to the database only, because it doesn't have the cache. So it will go back to the database and gets the answer, and it will store it as a cache again. So when the user again asks the same question, it can retrieve as the cache actually.
And is this like a library I could use right now?
Yeah, it is a library in Python itself. So you could integrate it, and it is embedded with LangChain now. So if you are building with LangChain, which is precursor for all the RAGs build now, you could use it, and many multimodal generation like images, videos, or also GPT cache are supporting, but it is not up to, it doesn't support in a much bigger level, but text-based, it is a very big support actually.
Thank you.
Yep.
Other questions?
So my question is, how does it handle things like least privilege? Like if it's going through and sitting in between, and I've got 2 users that are both going through, and one has access to documents and one doesn't, how does it ensure that that second individual doesn't get something out of the RAGCache that they weren't entitled to see?
So are you asking about the privacy and security?
Yeah, the privacy, security, and the potential for like poisoning. Like poisoning the cache, that then it impacts all these.
Yeah, that is possible actually. Even the LLMs are vulnerable to prompt poisoning and everything. So cache poisoning, I don't think so that it would be much because it automatically updates based on the user queries. So when when the other user is about to poison the cache, it might recognize or might not recognize, but I haven't explored much on that. So I would better answer it if I tried it actually. Yeah.